This problem is going to be quite lengthy, so let's get into it here. We have this molecule here. We're using acid and heat to make a molecule with the molecular formula of C10H10O. Alrighty, so let's get into it here. What do we know about nitriles when we use acid on them? Do you remember? Well, it's going to undergo something where it's going to make a carboxylic acid. And I'll show you how that works, actually. I don't mind. I'm here all day. What happens first in this mechanism is we're going to protonate. And what I'm going to do is I'm actually going to simplify the molecule. I'm going to draw R and R just to simplify things quite simply. So an acid from our aqueous acid, right, this is done in water, we're going to pick up one with our nitrogen. And what's going to happen is I'm going to draw a squiggle here just to say there's more to the molecule, but I'm omitting it because nothing happens to them. Of course, this could form like a hydrate or something, but that's not what we're interested in, right? In the equilibrium of that's going to favor the ketone a lot more. Okay, I think I'm yapping, so I'm going to shut up and get back to what I was saying. So we have our protonated group here. What happens next is we're going to take water and we're just going to attach here, kick electrons to the nitrogen. So we can actually draw it like this now, where we have an imine and we have a water attached. Now the equilibrium of this is going to want to push out the water. It's going to want to send it that way, but what happens next, if we can counteract that by using some water, reform our acid, alrighty. There's going to be a little bit of a pattern here. We're going to notice we're going to take some more acid, so H+, nitrogen comes in, steals that baby, NH2 with a positive charge here. Okay, and what's going to happen next is hydroxide, or the hydroxyl group is like, I don't really like that. Goodbye. And then we're going to kick electrons onto the nitrogen once more. So we have NH2, right? This is almost an amide if you think about it. This has a positive charge, so water comes in, steals that, puts it onto the carbonyl, electrons I should say. And then simply what we do is this will be hydrolyzed. This is an amide. Remember, if you use water with an amide and you heat it, what's going to happen? You're going to make a carboxylic acid. I won't bother to draw that part. I think this is the harder mechanism to see. So what I'm going to do is I'm just going to draw a carboxylic acid where the amide or the nitrile was, sorry. So I like in my problems that I do, by the way, if you watch this channel, you notice the videos can be like 30 minutes long for a problem. I want to make sure that when you leave, you have all your questions answered. And if you don't have all your questions answered, if it's a very niche question, please drop them in the comments. So what we're really going to get is this here, right? We make an amide, and then we turn that amide into a carboxylic acid. So now we have this carboxylic acid, but what happens next is when we heat it, and we use our acidic conditions, what happens is, it's kind of weird, it feels backwards, we're in acidic conditions, but this thing's going to get deprotonated, and under that heat, right, it will have the negative charge, of course, but it's going to really feel that, and it's going to be like, oh crap, I can't take this anymore. It's going to make a double bond, that's cursed, and put it onto a carbon here. So we actually get a CO2 leaving group, and that's gas. Once this happens, even though the equilibrium for this, the chance of this happening is so low, but when it does, the CO2 just escapes the vessel. So what happens, right, if you do this in an open vessel where CO2 can't get back in, you're going to get an enol. Okay, this is irreversible right here. You know, there are ways to reverse it, but it's irreversible if you do your conditions just right. Okay, what happens next? Well, that's just really simple. It's just simple protonation, right? Because that carbon with a negative charge is like, hell no, I will not be negative, right? He's a very positive kind of guy. He's not negative. He's not like fluorine or oxygen or, those very nasty elements. He's just like, oh, I'm a nice little positive guy. Hydrogen, I see you don't have a home. I'll give you one. That's exactly what happens. This is our product right here. Kind of a simple one, but just to confirm, let's count our hydrogens. So let's go. Let's see. We have one carbon here. We have 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have H10. How many carbons do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. C10, and then we have one oxygen. And that there, guys, that there is the product that is in. I checked this with the solution in the back of the book. This is what you get. Hope you guys enjoyed. If you did, please drop a like, subscribe, comment. If you have any questions at all, I'd love to answer them. That is the most fun thing about making these videos is when you guys have questions and I can answer them. Have a wonderful day.